Hello, in this video I will show you how to draw the graph of a function using the table of variation. The first thing that I will do is to find the concavity and the convexity of this function. So when you see a negative sign, that means that the function is concave. So we have that from minus infinity to minus 1, the function is concave. So in this part here, the function is concave like this, and in this part here, so this here is minus 1, and in this part here the function is convex, and here it's 2, so yeah, it's 2, and then in this part here the function is concave, so it would be, so plus is like happy, so the function here is happy, and the minus is sad, so the function here is sad, and in this part here the function is happy, so it would be like this, so it's happy, so it's convex. Yeah, so that's the concavity. And now let's draw the function. So to draw the function, so we need to draw okay, let's draw the y-axis. So for the y-axis, let's draw this. Okay, this is the y-axis, and let's draw the x-axis like that. So this is the direction for the y and the direction for the x. And the first thing that you draw when we want to draw the graph of function, you draw the asymptote. So we have here, so to see the asymptote, so let's identify the vertical asymptote. The first one, so the vertical asymptote is when the function has an infinite limit at a finite point. So for example, we have here that the limit at minus 4 minus is minus infinity. So x equal to minus 4 is a vertical asymptote. And the same thing here for 2. We have a limit from the left is equal to plus infinity. So this one, x equal to minus 4 and x equal to 2 is a vertical asymptote. So let's draw them. So for example, this is minus 1, minus 2, minus 3, and minus 4. So this line here would be a vertical asymptote. Okay, I will draw it. I will use a different color for the asymptote. So for example, yellow. So this would be a vertical asymptote. And the same thing for 2. So 2 is also, so 2, this is 1, 2, 3, 4, 5, 6. The scale is not right, but this here I'm just showing the idea. So this is also a vertical asymptote. So this would be x equal to minus 4, and this x equal to 2. Right? And the second thing is the horizontal asymptote. So the horizontal asymptote, you just see the limits at minus infinity and plus infinity. So at minus infinity, we have a limit of minus 3. So y equal to minus 3 is a horizontal asymptote. And at plus infinity, we have a minus infinity limit, so we don't have an horizontal asymptote. There is also an oblique asymptote, which is something more advanced. You need to do more calculation to see if there is a oblique asymptote. But if you want to see that, maybe say it in the comments if you if you are watching this video. But I will just do the simple case, which is horizontal asymptotes and vertical asymptotes. So for the vertical ones, so you need to draw the, so we said that y equal to -3 is a vertical asymptote, so -3, so this is the horizontal asymptote, so this is y equal to -3, which is a horizontal asymptote. Okay, and yeah, that's it. Okay, those are the importance points. The second importance points are the critical points. So we have here, so I didn't complete this table, so we have here a 0. This should be a 0 here, and here is a 0, this is a 0, and this is not a 0, and this is a 0 here, and this is a 0. So f prime of -2 is equal to 0, f prime of 0 is equal to 0, f prime of 5 is equal to 0. But we see that the second derivative here is negative, so this point here is a maximum, and this point here is a minimum, and this point here is a maximum. So let's draw these functions. So these points. So the first point is -2, which would be a maximum. Okay, for -2, and what is the image of -2 is -1. So for -2, the function is equal to -1. So let's draw that. So this is -1, -2. So this point is a maximum. Okay, and yeah, this point here is a maximum. The second point is 0, which is minimum. So 0 is a minimum. What is the image of 0 is -2. So -2 here. So if you take -2, this point is a minimum. And finally 5 is a maximum. So 5, what is the image of 5 is 6. I won't be able, so I will add like more points here. So this is 4, 5, 6. So this point here is a maximum. So this is a maximum, this is a minimum here, and this is also a maximum. Okay. The third chain is to draw the inflection point. So how do we know if a point is an inflection point? Is when the second derivative is 0 and the second derivative changes the sign. So here we go from minus to plus, and we have a 0 here. So this is an inflection point. Same thing here. So we have minus to plus, and we have a 0 here. So this is a inflection point. So -1 and 6 are inflection points. And what is the image of -1? I didn't okay, I didn't add it. Okay, I will just check and return. So yeah, the image of -1 is -2 so let's write it here. So -2. All right, this is an inflection point. Okay, and here I did a mistake. 0, the image of 0 is not -2, is -1, is -3. So this would be a minimum. So this is an inflection point, and this is a minimum. And for 5, the image of 5 is 6. So this is an, all right, so this point here is a maximum and an inflection point. Okay, which is somewhat weird because, but let's just let's see how it will turn out. Okay, so let's start drawing. So these are all the steps that you need to draw a function, but now we will draw. So the first thing that to start with is so you start drawing from minus infinity to plus infinity. So we have that there is an horizontal asymptote at -3, but the function goes to minus infinity. So for this function to go to minus infinity, it should be under the asymptote. So it would be like this. So it will go like this, and it is concave. So I will extend the vertical asymptote, and I will start drawing the function. So it would go from this to minus infinity, like that. To make it clear, so it will go, and the function is concave, so this is a concave function. Okay, it's not my drawings are not are not very good, but that's the idea. So it will go like that. Second thing, so we draw this part. Function is decreasing and it goes to minus infinity. Second part is from -4 to -2, the function goes from -3 to -1. So, and it is also concave, so it goes from, so the image of 4 is -3, so this point here, so it goes from this point to -1, which is this point here. So, but it should be concave, so it would be like that. All right, and then the second part is from -2 to -1. From -2 to -1, the function would go from -1 to -2. It is decreasing, and it's also concave, but it will change convexity at the point -1. So it goes from -1 to -2. So it will go from this point here. So it will go like this, always concave, but here it will change convexity, and it will be like this. So it will go like this. So here from -1 to 0, it is decreasing, and it goes from -2 to -3. From 0 to 2, it will go from -3 to plus infinity, because we have here so from -3 to plus infinity, because we have here a vertical asymptote, and the function is always convex. So it will be like that. It will be like this, something like this. Okay, sorry, so it will be, and convex, increasing, and it goes to plus infinity. Then the image of 2 is 0, or the limit from the right of 2 is 0, and here it's increasing, it goes to 6, but it is concave. So 2 here, so it will go from 0, so from this point to this point, and it should be concave, so it would be like something like this. All right, but okay, sorry, I did a mistake. So this is the 6 is the inflection point. So 6, the image of 6 is 4. So